Well, so today we're going to be doing the week 9 term 2 AMS quiz for math, and let's start. So the first question, KLMN is a parallelogram. LM is 5, MN is 3, LN, so let me draw that really quickly. LN here is 3.2. HG is an arc of the circle centered centered at K and radius 1 centimeter. So that's all our measurements that were given. Now, to the nearest degree, what's the measurement of LKN? LKN, this angle over here, they want what's it? Now, what we know already is this is a parallelogram. So in a parallelogram, opposite sides, opposite angles are equal. So this and this angle here are equal. So we can find this angle with the cosine rule. Cosine rule, which states that cosine m is 5 squared, or well, a squared plus b squared minus c squared over 2 times a times b. But I'm gonna write it in numbers. So 5 squared plus 3 squared plus minus 3.2 squared over 2 into 5 into 3. Now, once you do this in your calculator, you're going to find cosine m. What I just do is I say m is cosine -1 of this. And I put that into my calculator. Once you do that in your calculator, you're going to find angle m is equal to 30. It's going to give you a decimal that rounds up to 38 degrees. That's how you solve part A. Now, moving on to part B. They're asking us, rounded to the nearest whole number, the area of the shaded region. So they want, let me write everything again. They want the area of the region without this. So, wait, there's 3 here, 5 here, and now we know this angle is 38 degrees. Now, what they want is us to find the area of HLMNG without HGK or HG, the arc itself. You need to subtract it. So what we're gonna do is we have to find, we need to find the area of the parallelogram itself. And we know area of parallelogram is equal to base times height. Now we need to find the height. How are we going to find the height? We have an angle here and we have a right triangle. You have your angle, you have the side opposite to it, and you have your hypotenuse. So we're going to use sine rule. We're going to use So sine, your angle here, which is 38, we found it, equals h over 3, h over your hypotenuse. So then you do h equals sine 3 times sine 38. Long story short, we're going to find it equal to, let me do it in my calculator really quick, 3 times sine 38. You're going to find an answer like 1.85, okay? That's what we're going to get as our answer. Or something like this, rounded. This is rounded. So what we do next is, this is our height. We multiply it by our base. So times 5. When you multiply this number by 5, you get something around 9.23, I'd say. Actually, let me use the numbers I'm using here so I don't confuse anyone. You get 9.25 when you do this exactly. Now, what we need to find now, so we found the area of the parallelogram. It's equal to 9.25. Now we need to find the area of the arc. I'm just going to draw it like that. Now to find the area of an arc, we need to use the theorem, which is theta over 360 times, times how do you find the area of a circle, which is pi r squared. So times pi r squared. Now let's substitute. It's equal to 38 over 360 times pi 1 squared. We can remove the 1 squared because it's just 1. Now once you do this in your calculator, which is 38 over 360 times pi, it's gonna give you 0.3316, something like that. Now what you're gonna do is now 9.25 minus this, which is 0.3316. Let me do it. 9.25 minus your answer is 8.918, something like that. What we need is nearest to the nearest whole number, so you're gonna round it up to 9. So that is our area of the shaded parts only. That's how you solve part BI, and now let's solve part BII, which is asking us the perimeter of the shaded area. Now how do we find the perimeter of a parallelogram? You just add all the sides. So 5 plus 3 plus 5 plus 3, which is 16. That's the area of a parallelogram. Now, the perimeter. Now the perimeter of an arc is theta over 360. So the angle over 360 times pi times r. Times 2 pi r. So times 2 pi r, which is 1 here. Now put all that in your calculator. You're gonna get equal to 15, or not 15 exactly. You're gonna get it, let me tell you the decimal. 38 over 360 times 2 times pi gives us, you're gonna get 15.336, which rounds down to 15. And that's how you find the last part. That's it for question 1. Let's move on. Okay, so here we go. Now next question, which of the following vectors is equal to mn minus kn? Now we need to look. Vectors are directional, so it matters which direction they go. So we want mn minus kn. And what's that gonna be? Once you remove these two vectors, you're just gonna be left with what connects them. This is your resultant. So you're gonna be left with mk, because that's how you, like, when you remove these two, this is the only way you can get from m to k. It's like, yeah, it's like you're removing the n from both ones. So yeah. Now next question. Okay, so now they want us to add two vectors. So going from KL and LQ, where's LQ? Yeah. So it's technically asking you, how do you want to go from K to Q without taking this route? Simply, you're just gonna have to go K, Q. Wait, let me draw it with a different color. Just gonna go from K to Q, direct. Now, if they asked you, how do you go from K to Q, or which of the following is equal to KQ, you're gonna tell them it's KL plus LQ. But that's how you find this answer. So your answer is KQ, vector KQ. Let's see. KQ, there you go. Next question. Now, which of the following is the circumference of a circle of radius 4 centimeters? Now, we know to find the circumference of a circle, it's equal to 2 pi r. Now, we need to substitute r given into this. 2 pi r is 4. So 2 times 4, we're going to substitute that with 8. So our answer is 8 pi centimeters. Next question, what's the area of a circle? Now, area of a circle equals, it's pi r squared. So our radius is 5 squared pi. Same thing. That's your answer. You just have to memorize the formulas for this one. Okay. The diagram shows the results of a coding test for two groups of students labeled class M and class N. The mean score is 59.5. and for a class M, and the mean score for class N is 62. Students pass this test when they score 50 or above. Now, looking at the mean scores from students from class N, they claimed that they did better than class M at the test. Why did they not? That's practically what the question is saying. Now, more students in class M than class N passed this test. First of all, you have to look about, we know we need over a 50. Now, when you're looking at the numbers over 50, it's obvious that class M was always getting higher. They were getting in the 60s a lot and in the 80s, way more than class N. That's why it's one of the options, of course. If you ignore the weakest two scores in class M, the students in class M did better than those in class N. So if you ignore these two scores, looking at this pair of the data, class M was scoring way more than class N. This is of course true. More students in class M scored 80 or above. As we can see, yes. And then last one, all of the above. Since all of them were true, it's all of the above. Now here you have this question. A cyclist rode 3 consecutive laps around a flat 10-kilometer track. The graphs show how the speed of the cyclist varies in his second lap around the track. The origin of the graph refers to the starting point. Now, approximately at which distance does the biker start the longest straight section of the track? Now, we know when he reaches a straight part of the track, it's a straight line on the graph. The longest one you could tell by looking at it or by eyes or by calculating how many boxes it spans over. This is the longest one. He starts it at 5 kilometers. And that's your first answer. What's the lowest speed recorded during the second lap? So now you need to look at the lowest speed. You need to draw a line by it, and it's somewhere around like here. 14. You could, or wait. It's, yeah. At how many, they're asking us at how many kilometers. It's somewhere here, so it's closer to 8. So it's around 8 kilometers. At about 8 kilometers, as you can see. What can you say about the speed of the cyclist between the 4th and the 5th kilometer? So you're looking at the speed of the cyclist between this and this. It is going upwards in a slope, so it is increasing. Now that's it. Now, which of the 5 tracks is marked as, which one of these tracks is the most likely the track he was riding on? Now we need to look at your question or your graph. How many straight lines do you have? 1, 2, 3. You had 3 parts where he was riding on a straight line. What does that tell you about the shape? It has 3 sides. Technically, like not really 3 sides. It doesn't have to be angular, but it has 3 straight lines. And when you look here, you have 1, 2, 3, 4, 5, 6, 7, 8, and then 9, then 10. So definitely not this one. This is a big no. Let me make my X smaller. Now looking at B, you have 1, 2, 3 straight lines. Yes, this is most likely it. But let's look at the other options. Here you had 1, 2, 3, 4. 4 parts. So technically no. 1, 2, 3, 4, 5, 6. So not really. And here you had 1, 2, 3, and 4. So the only one that actually had 3 straight lines is B. So that's why it's your correct answer. Now this question is about wind. Now it's telling you a research team is building wind-powered stations. Sorry, the thing cut. A research team, they're building wind-powered stations. The stations use power of the wind to create energy. The research team measures the electric energy in kilowatts hours. The team builds the model with the following specifications: height, number of blades 3, length of one blade 25, maximum speed 20 rotations per minute, price, turnover, maintenance, efficiency. So, yeah. Now let's read the first question. Which of the following statements can be deduced from the specifications of the model? So, first option says the maintenance cost of the power station depends on the speed of the wind. The maintenance cost is per kilowatts generated. The kilowatts are how much energy is generated, and it has nothing to do really with the speed of the wind. Just how often the wind comes. Like if it comes once really fast, okay, it's gonna push it. But if it's coming like in less distances, in less amounts, over longer distances, it's kind of doing more, so it's not really about the speed. Now, so this one's wrong. The maintenance cost of the power station corresponds to approximately 10% of its turnover. Now, turnover is 0.10 Zs. When you want to make it into percent, you multiply it by 100, which is 10%. That's it. The construction of 3 such power stations will cost more than 7 million Zs in total. You just have to look at the number here and multiply it by 3. You're gonna get higher than 7 million, which makes it true. Power station is not operated on exactly 3 days a year. That would be true if our year was made out of 100 days, because it's 97% of the year. So 97% of the year it's working, so times 365, and then you'd subtract from 365. But technically this would only be true if our year had 100 days, not 365. So now, next part. The research team proposed the following equation to estimate the financial gain GZs over a number of Y years if they build the model described above. So G equals 600,000 Y minus 2,400,000. So based on this formula, what's the minimum number of years in operation required to cover the cost of construction? Now, so what we need to do is we need to find, okay, so this is how much it's producing and this is how much it took to build it. So 600,000 Y equals 2,400,000. And then you do 24 million, that divide by this, so Y equals 1, 2, 3, 4, 5 over 6, 1, 2, 3, 4, 5. And then you remove the zeros with each other, you'll be left with 24 over 6, which is 4. Now, the last one. This one is arguably the most annoying, I'd say. So, we know from the question that, let's go back to the question. Now, the blades are 25 meters. So that means that this is a blade. When it goes in a circulation, this is its radius. So 25 meters is our radius. And it goes at 20 rotations per minute. Keep those in mind. Now they want the maximum speed at the end of the rotor's move. Now to find the maximum speed, we need to find the angular velocity. The angular velocity is the rotations per second. So it's equal to rotation per second times 2 pi. Okay? We're going to calculate this in radians. Over 1, but I'm not really going to put over 1 now. So, angular velocity equals. Now, rotations per second. They gave us rotation per minute, which is 20 rotation per minute, 1 minute. So 1 minute is 60 seconds. Now, we can simplify this to be 1 over 3. So we have 1 over 3 rotations per second times 2 pi, which equals to 2 pi over 3. That's our angular velocity, it's in radians. Now, to find our actual velocity that they're moving, or the speed, it's equal to 2 pi over 3, or your angular velocity, times by the radius. By the radius, which is 25. So then you're going to be left with, do this on your calculator using radians, but make sure please that you convert your calculator back to degrees once you're done. So you'll be left with 50 pi over 3, which is equal to 52.3 or something like that. Or this is a rounded digit. Now you're going to say, oh, but that's not the answer. But this is 52.3 meters per second, because the 25 we used was in meters and we're using seconds. So we want it in kilometer per hour. We know 1 meter per second. Memorize this conversion. It's equal to 3.6 kilometers per hour. We need this, so I prefer you memorize it because we need it for physics, we need it for math, we need it everywhere. So you're going to do 52.3 times 3.6. It's going to give you something like 188.3. This is the closest option to it, and that's how you find your maximum speed. Now, that's it for this question. Let's move on to the next. Okay, for this question, it's practically just read the question and cancel out the odd, like, process of elimination, simply. Select the figure below that select one of the figures above that fits the description. Triangle KLM, right triangle with right angle K. So first of all, delete anything that's not a right triangle and delete anything that's not a right angle at K. You're left with only these three options, being at angle K, or having a right angle that's K. Line KM is less than line KL. So KM is shorter than KL. This is true here. KM is shorter than KL here. No, this is definitely wrong. Here it's longer than KL. Now here, KM is shorter than KL, yes. So now our answers is either figure F or figure B. Let's read. N is the midpoint of the line KM. So N is the midpoint of the line KM. This is true in both. And P is the midpoint of line KL. P is the midpoint in line KL. This is also true in both triangles. Q is a point inside the triangle. Both of them have a point Q inside them. But line PN, so this, is greater than PQ. Line PN, PN is greater than PQ. Now here, look. They both are starting from the same point, but one is ending and this one is at a slant higher than it. So PQ here is longer than PN, so this is wrong. Here, PQ is shorter than PN, making figure B the correct answer. And this is correct. Now let's move on. Okay, this question, it's the question with the cone. And I really hate this question. Anyways, let's solve. You need to find sector angle X. Now, what is the sector angle X? It's practically this angle when you open the triangle up, obviously. Now, wait. Okay, yeah, sorry. I don't know what happened there. So anyways, we know that this arc AB's length is equal to, well, this arc AB, of course. And it's equal to 2 pi, because you know, sir, that the area of the arc's length is like the circumference, almost. Like you need to find the area of the circle's circumference to find the length. So it's 2 pi r. Now r is 4. So 2 pi 4, which is 8 pi. So we know the circumference of this is 8 pi. AB is 8 pi. This is the whole circle. Now we want the sector angle. So, because look, this is like AB is practically this entire thing but opened up. So it's the entire circumference. So it's 8 pi. Now we want the arc length, which is gonna be 8 pi equals x over 360 times 2 pi, your new radius, which is OA, which we know is 10, or times 10. Now, so we want, so 8 pi equals 20 pi over times x over 360. So x practically equals 8 times 360 over 20, which is gonna equal 144. So yeah, that's your answer for part A. Now for part B, what's the area of the shaded region? Now the area for the shaded region, which is this, is equal to the area of this minus the area of the triangle. Now, to find the area of this arc, we know its sector angle, which is now we found to be 144 over 360 times area for us, which is pi r squared, which is 10 squared. You're gonna get 40 pi, which is also the same as 125.6, around that. Now for the triangle, we know we need to use the rule, which is area of a triangle equals half side times side times angle, sine of the angle. Once you do that in your calculator, you're gonna get that it's equal to 29.3 or something like that. Now 125.6 minus your 29.3 is gonna give you something like 96.3, which you round down because they wanted the closest centimeter to 96, and that is it. Now, next question. The surface area of a right rectangular prism with a side length 6,4 whose height is 10 is something centimeters squared. Now we need to memorize the formula. Surface area of a right angular prism is length times width plus length times height times width times height. Sorry, plus, not times. So, sorry, 2 times all of this, my bad. So 2 times 24 plus 60 plus 40, which when you put in your calculator is gonna be 248. Now, on to the next question. Now, okay. Next question, it's telling us that the solid cylinder has a volume of 125 pi centimeters cubed and a height of 5 centimeters. The radius of the cylinder is. Now first we need to, of course, know the formula of the volume of a cylinder. So volume of cylinder is equal to pi r squared height. Now we have the volume, so it's 125 pi equals pi r squared, which is 5 squared. R squared is which we don't know, sorry, times height, which is 25. Yeah. So now we're left with 125 equals 25 times r squared. 125 divided by 25 gives you 25. Or wait, what? Is it? Sorry, this is 5. Where did I get 25 from? My bad. So 125 divided by 5 is 25 times r squared. Equals, sorry, my bad. 25 equals r squared. I keep making mistakes. Anyways, so now r equals 5. Now we need to memorize that 5 because we're going to use it in part B. So we know our radius is 5. Because now we need to add the new volume. So the new volume is going to be the volume of the cylinder, which is 125 pi, plus the volume of the cone. Now volume of cone equals third pi r cubed height. If I'm not mistaken. Yeah, no, I'm not. Now third pi r cubed is 5 cubed times height, which is 9, sorry. Third, okay, so now let's put it in our calculators. So third times 5 cubed times 9 is, and I'm getting something wrong. Okay, yeah, my bad. So I was reading the formula from the paper in front of me wrong. It's r squared. Sorry, guys. Memorize this formula. It's r squared. I don't know where I got the cube from. That's a different formula we're going to use later. So now we got the correct one, which is 75 pi. That's your answer. So 125 pi plus 75 pi, they're going to give you 200 pi. And that's how you find this answer. Now, for the third part, it's a question that actually comes a lot in the IG math, paper 2 specifically, if you're doing it. They're telling you that you have a solid that's similar to part B, except here its volume is 5,400 pi, whereas yours was 200 pi. Now you want the radius of your new solid, which is x, and your old radius was, we found to be in the first part, 5. Now you're gonna say, oh, well, let's just cross multiply. No, because look, this is in centimeters cubed and this is in centimeters. So if you want the centimeters cubed to become centimeters, you do that. Now you do this in your calculator on this part is gonna equal to 15 equals x over 5. Wait, it's, again, my calculations are all wrong today. It's equal to 3, which equals x over 5, making x equal 15. Yeah. And that's it for this question. Now let's move on. Now the volume of the sphere, radius 6 centimeters, is something. Let's find it, because we know the formula for a volume of the sphere is 4 over 3 pi r cubed. Here it's where it's cubed. Now, so it's 4 over 3 pi, we're going to keep it as pi, r cubed, which is 6 cubed. Once you put that in your calculator, now you actually should get the correct answer. Times 6 cubed, which is, 288 pi. That's your correct answer. Now for part B, they want the height of the water once you add the ball to it. How do you do this? You're gonna find the height of the water without the ball, and you're gonna find the volume of the cylinder with only the water, and the height of the cylinder with, the volume of the, you're gonna see what I mean now. You're gonna find the volume of the cylinder with the ball or the sphere in it, and without, or with only water. Let me start solving because I feel like I'm confusing everyone. Now we know volume of a cylinder, again, it's pi r squared height. Now we know that our volume of the sphere is 288. So we're gonna take it as if that was our normal volume. So we're not gonna take it as if it were, we're gonna make it our volume of the cylinder, because we want to know how much percentage of the cylinder it would increase the height. So equals pi, 288 pi equals pi r squared, r is 7, height. Now pi cancels with pi, you're left with 288 equals 49 h. H in this case will equal to 5.87 or something like that. Now we need to find the volume of the cylinder that's taken up when it's only water, which we know it's 1 liter of water, which is 1,000 centimeters cubed. So 1,000 equals pi r squared h. I'm going to replace the r squared with 7 squared h. Now we need to divide the 1,000 divided by pi and by 49. And you'll be left with, so it's 1,000 divided 49 pi equals height. And height is going to equal, in our second case, to 6.49. Now, once you add these two heights together, you're going to get your new or final height. 5.87 plus 6.49 is going to equal 12.3, which you're going to round somewhere approximately to 12, because they wanted it to the nearest centimeter. And that's it for this question. Now, for this question, we've seen it like a million times, but let's solve it. The maximum speed attained during the trip is, you need to find the area of the graph, which is a trapezoid. So 7 to 8 is 1 hour, or 1, plus small base, which is 750 to 75. So it's 55 minutes. 55 minutes, you need to find the percentage of that hour it's in. So 55 from an hour is, again, my calculations are off. 45 over 60. It's not 55, because it's 50 minus, So 45 over 60 is equal to 0.75. Now 1 plus 0.75, which is small base plus big base, over 2 times height, gives you your entire distance, which is 63. So we're gonna do all of that. You're gonna get 0, well, let's actually 1.75 divided by 2. It's gonna be 0.875 h equals to 63. Divide 63 divided by 0.875 is 72. Now, using our 72 now, the maximum acceleration reached during the first 5 minutes. So during the first 5 minutes, the acceleration was 72 divided by the time. But the time in hours, not in in minutes. So we know it passed 5 minutes. 5 minutes of an hour, which is 5 over 60. 5 over 60 can be written as 1 over 12. So 72 over 1 over 12, which is the same as 72 times 12, which is 864. And that's your final answer. Now moving on to the next one. Okay, now here we have a circle and telling us OA and AOB are perpendicular radii and length 35. So this is a right angle and this is 35 since it's an isosceles triangle. Using 22 over 7, what is the area of the shaded bound of the arc? Now you want to find, again, this. So how do you find this? You need to find the area of the arc minus the area of the triangle. Area of the arc, again, how do we find it? You're going to find it by doing theta over 360 equals times pi r squared. Now 90 over 360, I'm just going to write it as 1 over 4 times pi, which they asked us to use as 22 over 7, times r squared, now 35 squared. You're gonna get an answer like 962.5. Now we need to find the area of the triangle. The area of the triangle is just base times height divided by 2. So 35 squared divided by 2, which is gonna be 612.5. So 962.5 minus 612.5 is going to give us 350, which is our final area of the shaded part here. There you go. Now for question 17, we know that a circumference of a circle is 2 pi r and the area is pi r squared. Now the area of the circle whose circumference is 12, so 12 equals 12 pi, 12 pi equals 2 pi r, is the area is k pi. What is k? Now to find the area we need the radius. To find the radius you use the circumference. So 12 pi divided by 2 pi is 6. So your radius is 6. Now we use our new radius in this equation. So r squared, which is 6 squared pi, 6 squared is 36. And they don't want you to keep it in k pi, so 36 pi. That's your answer. Now, moving on. In the given figure, PQR. So, PQR is an arc of radius r, we don't know the radius, and length 15. What is the length of RQR? So now here we need to use radians and we need to use the formula for segment, like segment theorem, but for radians. So let's start. When you're using radians, the arc's length in rad, I'm just gonna write in radians, equals theta, which is your angle, r. So now, what we know is our whole arc is 15. what is 15? So the area of this arc, or the arc length, is 15. It's equal to theta. What is theta? We know 90 degrees is pi over 2 plus pi over 3. So 90 degrees, which is a right angle, is in radians pi over 2. So this is your angle. This is your theta. So once we do that in our once you add these together, you need to make the denominators equal. So they're going to be 2 pi over 3 plus 3 pi over 2. It's equal to 5 pi over, sorry, you need to multiply the denominators too, sorry, 6 over 6. So this is your angle in radians, of course. So you need to switch your calculators back to radians to answer. So 5 pi over 6 times r. So when you do on your calculator 15 divided by 5 pi over r over 6, you're gonna get that it's equal to r is equal to 5.72. Now we're gonna take this again. This is our radius. They want arc they want arc QR. This, only this. So we use this formula with r now. We use pi over 3 times r, which is 5.72, is going to give you just 6. And that is it for this question. Now moving on to our last. Okay, so the figure below shows a sector of a circle of center O and radius 10 centimeters. Now you need to find the area of this sector. Now the area of this sector is gonna be what's it called? Theta over 360 times pi r squared, of course. Theta is 108 over 360. Move your calculator back to degrees if you didn't from the last questions, because I know a lot of people that got so many mistakes in their exams just because they kept their calculator in radians. So 108 over 360 times pi times 10 squared. Put that in your calculator, you're gonna get 30 pi. And that's your final answer. That's it for this quiz. Hope you had a nice day. Bye. Okay, so hi again, guys. I realized when I was reviewing the video that I'd forgotten to solve question 2, or I skipped past it by mistake. So we're gonna solve it now. So referring to the figure below, O is the origin. OA is, so OA in this direction is A, and OB in this direction is B. Now, which of the following is true? First, let us analyze what we're looking at in the triangle itself. Now, we know, first one is they want you to find OM. Now, to find OM, we need to go from OA to AM. So, let me draw that in a different color. So, we need to go from OA to AM. But we know that AM, we don't have the value of AM. So, what we need to do is we need to find AM. Now, to find AM, we know that AM is in a 1:2 ratio. So we need to find AM, we need to find AB. So we need to find AB. To find AB is equal to AO plus OB. So AO plus OB gives you AB because it's AB. It's a vector, it's going in this direction. So we need to find, to find AB, it's AO plus OB. AO is negative A, because A is a vector going this way. You're going opposite, so it's negative A plus, B is going in the same direction, plus B. So that's how you find AB equals this. Now, what we know, or you could rewrite it as B minus A. Now, we know that AM is half of it. So AM, because they told us AM is in a ratio of 1:2, so it's half of AB. So AM equals half. AB is B minus A, so half B minus A. Now, using the information we have, we can finally find OM. Now we know that it is OM is, so OM is this one. OM is practically OA plus AM. So A plus, because OA is A. Let me again change color. You're using this one. You're finding this plus this now. So we're going using A plus AM, which we found to be half B minus A. So what's it called? So A plus half B minus half A. So it's 1A minus half A gives you a half A plus half B. So then you're gonna factor out the half. You're gonna be left with, let me do it over here actually, half A plus B. And that is vector OM. Now I'm gonna put a black box around the 3 correct vectors. AM is this, AB is this, OM is this. Now we're gonna remove the pen and we're gonna go to our options and we're gonna look for the 3 options that we found by doing all of that. Again, have a good day. Bye.